Today we're going to explore the discriminant a little bit more, picking up from what we did last time. So we know that our discriminant is going to be that quantity under the square root. And we are going to take a look at what that is going to tell us. More than if it's negative, we know it just doesn't have any real roots. It's going to give us something else. Okay, and we can break this up into something called rational, irrational, or imaginary. Okay, rational being a number that can be expressed as a ratio. Irrational being a number that never ends. So like the square root of 2 or pi are irrational numbers. And then imaginary being like what we have been dealing with, a negative value under the square root, meaning it's not going to cross the x-axis. So it says case number 1, the discriminant is a perfect square. So if we solve this discriminant, we plug in our values, I have 3 squared minus 4 times 1 times negative 10. Okay, so I get 9 plus 40, which gives us 49. And yes, it is a perfect square. So the roots, okay, well, if we were to actually plug this into the quadratic formula and solve, I would have a negative b plus and minus the square root of our discriminant, we've already done that work, divided by 2 times a, and 2 times a is 2. Okay, so if we solve this, now I have a negative 3 plus and minus 7 over 2. So by simplifying, we would get a value, negative 3 plus 7 divided by 2, negative 3 minus 7 divided by 2. Either x would equal negative 5 or a positive 2. So number in nature, what does that mean? Well, number of roots. So we got 2 roots. Okay? And the nature, well, these numbers here are both rational values. And if I look at the graph of this, I can see it's crossing the x-axis at a negative 5 and a positive 2. Okay. Case number 2 we're going to look at is what if it's not a perfect square. Okay, so again, we're going to solve for the discriminant. So I'm going to have a negative 6 squared minus 4 times a times c. And solving this, so I get 36 minus 28, and so that's going to simplify down to 8. So it's not a perfect square, but it's a positive value. Okay, completing that quadratic formula, I would have a negative b plus and minus our discriminant all over 2a. So we're going to simplify this. This is going to simplify down to, if I were to do this work over here, I could say square root of 4 times square root of 2. I know square root of 4 is going to be 2 radical 2. Okay, so keep in mind, I can reduce all of these by a factor of 2. And so now I'm going to get an answer that looks like 3 plus and minus radical 2. Okay, so what could we say? The number of roots. I get 2 roots. In the nature, I can describe these as being irrational roots. Now, something else that we didn't mention up above, but I'm going to throw back in there because it's going to happen here, is these are also unequal. Right? Notice that I would have 3 plus square root of 2, 3 minus square root of 2. Same thing here. 2 roots, they're rational, but again, they're unequal. So continuing on with the third case. Okay, it says the discriminant is equal to 0. So when I plug this in and I simplify, I have negative 10 squared minus 4 times a times c. And if we simplify this, this gives me 100, this gives me 100, and it does simplify down to 0. So the roots, so I have negative b plus and minus the square root of 0 over 2. Well, square root of 0 is 0. So this would give us 10 plus and minus 0 over 2, or really this just simplifies down to either 5, or I could also get 5. 10 plus 0 is 10 divided by 2. 10 minus 0. Okay, so what does that mean? So again, we get 2 roots. It's just they are equal roots, and they are rational. roots. Okay, and now our last case is when our discriminant is less than 0. Okay, so plugging it in, I'd have a negative 8 squared minus 4 times 1 times 20, and I'm going to divide that by, oops, nothing, sorry, got too carried away there. I'm going to simplify that, is what I'm going to do. That's going to get us 64 minus 80, and when we simplify that, I get a value of negative 16. So we saw this earlier. We know what should happen here. We should be getting some imaginary values, but let's plug that in and check it out. So I'd have a negative b, so that turns out positive, plus and minus our discriminant, divided by 2a or 2. Okay, simplifying this would simplify down to 4i. 16 is a perfect square. The negative gives you the I value. And then simplifying these, I can reduce them both by a factor of 2. I'm going to have 4 plus and minus 2i. Okay, so again, the number of roots, I get 2 roots. The nature, they are unequal. And they are, in this case, imaginary. So using these 4 cases, we can kind of answer what type of roots we are going to have. And so it says in the last session we explored case 4 extensively. In the cases where the discriminant is negative, the roots are imaginary and it doesn't have x-intercepts. So we're going to only use our discriminant and we're going to see if we can determine the number and the nature of roots. So this first one here, our discriminant. So I have b squared minus 4ac. So this gives me 49 plus 32. So adding this up, this is 81. So this is our perfect square. And we said when this happens, we get 2 roots, but they are unequal and they are rational, meaning no negative under the square root. Okay, we'll try this one here. So again, we're doing our discriminant. B squared minus 4 times a times c. Okay, so I get 64 minus 100, which is going to get me a negative 36. So there's that negative under the radical. You're going to get 2. They will be unequal, and they will be imaginary. We'll try this guy. So we have b squared minus 4 times a times c. So here's 16 minus 16, and we get 0. Okay, so what does that mean? So we get 2 roots, however, they are equal in this case. And they will also be rational. Okay, now you could have flipped back to the front if that didn't make sense, and take a look at the cases that we have to try and help determine this. That's a way to do that. We're going to consider the quadratic function. We're going to determine the number of x-intercepts of the quadratic function from the value of its discriminant. So what we've been doing, same thing. But then we're going to try and sketch its graph on the axis given. We're going to say that the parabola is tangent to the x-axis. So we're going to take a look at that. Okay, so working with the discriminant, I would have b squared minus 4 times a times c. So we get 16 minus 16, which gives us 0. So that's kind of like that last case that we just looked at. Okay, meaning I have 2 roots, they are equal roots, and they are rational roots. Okay, so we're going to use the rest of that quadratic formula to actually plug this in and find those roots. So we would have b squared, negative b. So our negative b, which is negative 4, so I'd have a negative 4 plus and minus the square root of b squared minus 4ac, which we know is 0, divided by 2a, a being 1, so that's just 2. So the square root of 0 is 0, so that's going to get me 4 plus 0 over 2, and that's going to get me 4 minus 0 over 2. And they are both going to reduce to 2. So here's my 2 roots, but they're equal. and it's rational. Okay, so graphing this, okay, I could take a look. I know the root is at 2. I really can only touch the x-axis once. Here's your parabola. And I could graph this here, and I could tell you that's going to be the y-intercept of 4. So being tangent to the x-axis, if you go back to your days of geometry, tangent meaning it only touches at one point. So if it's tangent to the x-axis, it's only touching it at one point, and that one point is because these roots here are equal. Okay, so it says describe the following graph. Well, we know it's a quadratic. We know it's going to be opening up because I have an a value here that's greater than 1. I should say greater than 0. It is 1. So if it's greater than 0, it's positive. It's going to be opening up. And now I could describe it a little bit more by looking at its roots. So doing our discriminant, so I could say b squared minus 4 times a times c. Okay. This will give me 4. 4 times negative 15, I get a negative 60, so minus a negative 60, so that's going to get me 64. That is a perfect square. So if it's a perfect square, I could say to you, it's going to have 2 roots. They will be unequal, but they will be rational. Okay, and then number 5 is saying, for what values of a will the parabola not cross the x-axis? Well, if it cannot cross the x-axis, I know then the discriminant, that b squared minus 4ac, would have to be less than 0. Okay, so let's plug it in. So I have b squared minus 4 times a times c has to be less than 0. So now that gives us an equation that we could solve for a. Okay, so I have 16 minus 8a is less than 0. I'm going to subtract over the 16. So now I have negative 8a is less than negative 16. And so now here, when I solve, please be careful, you're dividing by a negative value. When you divide an inequality by a negative, your sign switches. And so we have a is greater than 2. So for this parabola, for what values of a will the parabola not cross the x-axis? For the values where a is greater than 2. Okay, bring any questions that you have into class. We will talk about this in class, and I hope you guys have a great day.